For our final project, we tried to figure out how to get your name in shining lights. The motivation for this project was to find what affects awards and nominations for movies. We wanted to see what it would take to make a good movie. Can you throw money at it? Can you make a movie in a specific genre? What will make some movies successful? We wanted to find patterns in movie nominations, whether that's ratings or budgets over time.
We thought this topic was important to study because movie nominations should be fair and awarded to the movies that deserve it the most. We wanted to search for patterns that might suggest nominations are biased. We wanted to know if good movies have higher critic ratings and if they perform better at award ceremonies. We also felt that it was important to see what exactly being a good or successful movie means.
So we studied 3 data sets. The first one was about movies on Netflix, Prime Video, Hulu, and Disney+. So here's a snippet of the data. It has title, year, target age group, and then a few ratings, and then whether it's on any of these 4 streaming platforms. So we felt that the important attributes were target age range and the genre of the movie, in addition to obviously its title. So in this data set, there are 16,744 entries, and they span a time frame of 1902 to 2020. Our second data set was a complete IMDb movie data set, which, as you can see, has 2 attributes for title, the year, and more specifically also the date that it was released. Another genre thing, its duration in minutes, the country of release, languages it was in addition to credits about several of the people on the movie. And then the most important part was that it has the average vote from users, the number of votes it's received. This data set also contains an attribute called Metascore, which is how we represent the approval of movie critics. In this data set, there were 85,855 records, and they span a time frame from 1894 to 2020. Our third and final data set is the Academy Awards from 1927 to 2015. And this data set contains the year of the ceremony, the award that was given, whether or not they won, the name of the actor or actress who won, and the film on which they worked. This data set has 9,964 records and spans a time frame from 1927 to 2015.
So throughout this project, there were a whole bunch of things that we did to process this data. Just a few examples, we're dealing with different column names like title versus original title, having to look at those and make some decisions on which we would use, for joins and merges and such. Also converting date published to date time, and then other pre-join processings like looking at the title column, case sensitive columns, and more. As you can see here, Notorious La Monte Peruta, which I know I pronounced perfectly, has another title, just Notorious. So making sure we look at that and making sure it lines up with our other data.
Analysis and visualization. As we mentioned before, we're looking into what makes a good movie. It's not the contents, because art is subjective, but in terms of whether a studio can do anything to ensure the success of a film. Can you spend more money to get a better movie? Can you focus on a specific genre? These are just a few of the things we explore. Now, before we begin, we must first state that we're defining a successful movie based on high user voter ratings on IMDb and Rotten Tomatoes. So we begin by importing all of the packages we'll want to use later and importing all of the data. As we mentioned before, a bit of the pre-processing was we converted the date published column of the IMDb data set into date time so that we can later use it as a way to look at trends over time. We then grabbed subsets of the IMDb and streaming data sets so that we can use them in our analysis without having to slow our analysis down by using the entire massive data set. And finally, we joined the IMDb and the streaming data sets, and we ended up using the original title column of the IMDb data sets because that appeared to agree best with the titles used by the streaming data set. So the first question we wanted to answer was, do movies targeted at different age groups perform differently? So we did this by grouping by age group and then graphing the distribution of average votes. So as you can see in this histogram, the distributions look to be approximately the same, and this is further confirmed by our descriptive statistics table, which shows that the mean average vote for all of these was approximately 5.5 plus or minus half out of 10, and this is within the standard deviation of each of the respective age groups. The next question we wanted to answer was, do different genres of movies perform differently? So similar to how we grouped by and then graphed age group, for this, we grouped by each of the genres and then graphed the mean and 1 standard deviation error bars for each of these. This is shown in the plot down here. where the green dots are the means and they are extended on either side by 1 standard deviation error bars. The population mean for the entire data set is shown in this light orange line. And just to show that there are values that lie within all of the standard deviations of all of the sets, I've also included a line at 5.45, which is within the standard deviations of each of the genres, with the exception of game show and news, which has 3 entries and 1 entry respectively. The next question we wanted to answer was whether movies on different streaming platforms are better rated, and are movies that are on more streaming platforms better rated. The logic behind that was because streaming platforms have to pay for the streaming rights to movies, it wouldn't make sense, for example, if Netflix was to pay for the streaming rights to a bad movie, because then no one would watch it and they wouldn't make any money. So in order to answer this, we created the similar standard deviation error bar plot that we use for genres, where again, the population mean is shown by a horizontal line in this purple. To answer the second part of the question of does being on more streaming platforms make it a better movie, we created this table where you can see that movies that are on more streaming platforms do tend to have a higher mean rating, but not a statistically significant one, as all of their standard deviations include each of the other values.
Next, we wanted to know, do better rated movies win more awards? Before we did that, we had to deal with percent signs showing up in the Rotten Tomatoes scores. So I wrote a quick function to strip that away and turn those ratings into decimals so that we could plot them more easily. Then I went ahead and plotted the Rotten Tomatoes scores against the IMDb ratings. The first thing you'll notice is that those 2 ratings are fairly consistent. If Rotten Tomatoes rated a movie pretty well, so did IMDb. As you might expect, better rated movies won more awards. Next, we wanted to look at how funding has increased over time. As you'd expect, with the economies growing, with the movie industry booming, more money will be put into the movie industry. But we wanted to look at how that was done. Just like the question before, we had to take care of the budget column. There were dollar signs, euro signs, and we had to take care of that. The first thing we did was strip away the dollar sign and turn that into an integer. If it wasn't in American dollars, we just converted that to a NAM. We understand that this will eliminate some of our data points, but we still believe that the sample is large enough to be representative. As you can see, we plotted funding against time. We did do funding in a logarithmic scale because otherwise it would be very difficult to see the funding from movies before about the 60s because the industry really exploded and there's a huge infusion of money. But as you can see, it does follow a pretty consistent exponential curve. And then also we highlighted our Oscar winners and our Oscar nominees. It does seem that they hover a little bit higher up on the funding chain, but not in an extreme sense. There are a few movies lower down across all years. So it is good to see that you can't necessarily just buy your way to success. Next, we wanted to see how have the ratings of movies changed over time. To look at this, we plotted the average vote on IMDb against time, just to see, do we rate old movies and newer movies consistently? What you notice is that for newer movies, there's a lot bigger range. There are a lot of pretty decent movies, but also quite a few not so great movies. And then for older movies, they're all rated pretty highly, but there aren't as many ratings. What we expect is that nobody's going back and watching bad old movies.
Next, we wanted to examine if better rated movies receive more awards and nominations. We mainly compared the Metascore, which is ratings by critics, and then user ratings from the IMDb dataset. For this visualization, we wanted to use SQL. First, we had to read in the data and convert the columns to date time. Then we converted the CSV file to SQL database. Because the Oscars data and the IMDb data do not have the same column names, we had to rename the columns in the Oscar data to match the IMDb data. Because SQL interprets column names as entirely lowercase unless specified otherwise, we wanted all of our column titles to be in lowercase, so this would not create problems later. Next, we wanted to split our database into 3 separate time periods. We did this because we have a lot of data, and if it was all in one chunk, then it would be very hard to understand. Our first time period we identified as the Golden Age of Hollywood, which lasted from our first date in the dataset, which is from 1927, to the end of the Golden Age of Hollywood, which is identified as 1969. Our second time frame was the rise of home video. That has been identified from 1980 to the year 2000. Lastly, our third table looks at the last 10 years of movies, which is from 2010 to 2020. Because the Oscar data has null values for movies that were not nominated, we had to replace the null values with 0, so we were able to plot them. The 3 plots from our data display that movies that are nominated or win are generally highly rated by both users and critics. Something important to note is that every time period has a decreasing number of years in it. For example, in the Golden Age of Hollywood chart, we have 40 years worth of data in it. In the Rise of Home Video chart, we have about 20 years in it. In the third chart, we have 10 years worth of data. This is important to note because if more years are in a data set, then it will appear that there are more winners. However, we know this is not the case because not all the time periods are the same for every plot. We did not have the same number of years in every single plot because in recent years, the amount of movies made per year has increased exponentially. If we had the same number of years in every single plot, then it would be too much data to look at one time. Our next section focuses on questions that were not directly related to our main project, but we still were interested in exploring. First, we wanted to know the number of movies that are nominated for Oscars each year. We were interested in this question because we wanted to know if more movies are being nominated for multiple awards, which would lead to the number of movies each year dropping. We were surprised to see that this has not been the general trend. While less movies are nominated now than in the mid-1900s, there seems to be a slight increase in the number of nominated movies after 2008, highlighting that more movies are being recognized for their work, which we think is a good thing.
Just like in the question before, we wanted to see if there was a change in the number of winners year over year. And similarly, nothing really has changed. The graphs look almost identical for Oscar nominations and Oscar winners, which is a good thing. It means that nobody's sweeping the awards.
The purple dots in the plot are the yearly averages for movie runtimes. In the third plot, you can see that they have pretty much leveled out at about 100 minutes, which we found very interesting.
Through looking at a multitude of aspects for movies over the past century, we learned that if a movie studio is attempting to make a movie which will be well received by the public, there isn't any single formula for a great movie. When comparing user rating across genres and streaming platforms, we found no statistically significant variation among the various samples. We also learned that while film budgets have been increasing over time, the proportion of these films which are being well received shows no skew towards those that are well funded. We see the same lack of correlation among those films which have won or been nominated for the Oscars. We also failed to find any notable trend in IMDb ratings over time, as there is no preference for old movies over new movies or vice versa. We also looked at critic reviews to see if they were a better predictor of Oscar performance. Again, we found that the density of Oscar winners simply followed the density of movie ratings, showing that there is no specific group whose ratings are a stronger predictor of award show performance. This all led to the conclusion that while many factors go into making a good movie, there is no single factor that can predict the quality of a movie. As a final note, we also asked a few questions about the data that we were dealing with. We had a hypothesis that as time progressed, more movies were being nominated for multiple awards, so we expected to see a downward trend in the total number of nominated movies per year. We didn't see this trend as the number of nominated movies has actually been relatively stable since the mid-1960s. We saw the same thing when looking at the number of movies which won each year. Finally, we wanted to see if movie runtimes have increased as the accessibility of movie making has increased. We didn't see this trend as movie runtimes have stabilized at approximately 100 minutes. Thank you. Good night.